Alright, principle of the process of conducting life cycle cost analysis, considering the non-monetary benefits of the asset, historic preservation, security, and safety. The overview. Essential aspect of conducting life cycle cost analysis to determine the cost effectiveness of any given construction, alternative identification, relevant input for the output qualification possible for these cost benefits, and facilitate informed decision making. Costs inform readily quantified benefits because they normally have dollar amounts attached. Benefits are difficult because they often tend to have more intangible in analysis. Benefits should be more important to cost to observe. Should be brought in the attention of the decision makers. Other quantifiable benefits of many investment decisions, especially industrial action applications, have stated goals defined with the required expected outcome, number of the kilowatts hour of the electricity produced per year, number of the aircraft overall per year. Though is not always quantified, but is often a respectable qualification provided with a potential measure of benefits associated with the investment. Benefit cost ratio may be determined by the output of the investment, quantified with the uniform annual cost derived with the life cycle cost analysis. Using an example to provide with the type of the output, type of the number of the kilowatts of electricity produced, benefit with the complemented aircraft overhauls benefit per $1,000 cost. The ratio must be compared with several different alternatives to assist selection of the most cost-effective, non-quantifiable benefits. Despite the efforts of the development of quantifiable benefits, their situation simply does not lend themselves to such analysis. Certain projects may provide with the improved quality of working environment, preservation, control, historic resources, safety, security of the building occupants, other similar quantitative advantages. They all may have difficult access to the benefits of the documented with the portrayed and life cycle cost analysis. In such instances, written accurate description of the qualified benefits must be done with the least preferred benefit of analyzing due to the subjective inherent lack of this precision. However, under certain conditions, the methods must suffice that the following guidelines reserve with qualitative statement that can be measured, make a positive contribution analysis, identify the benefits associated with the alternative under consideration, give complete details, identify benefits common in the kind of the non-same degree with all among alternatives, explain all differences in detail, to formalize inclusion of the non-monetary cost of the benefit of the decision-making process, the analytical higher process, if it should be employed with the analytical higher process, one step with a multiple attributed decision analysis, a method of the non-monetary attributed with the quality of the quantitative addition, common economic evaluation measure of the evaluating project alternative, the E1765-16 standard of applying analytical hierarchy process to multiple attributed decision analysis of investment related to project and products and processes, published in the ASTM International President Procedure calculating interpreting analytical hierarchy process scores project total overall desirability when making building-related capital investment decisions. Following these guidelines will help to advance the difficult tasks of the documentation of the intangibles of the measure of the non-economic terms like aesthetics, safety, morale, and habit, and so they value benefit cost analysis make informed decisions make easier. Quantify negative aspects. As noted, with the additional benefit of information concerned with the negative aspects, alternatives quantified where possible should be included and ensure the objective complete with the analysis information important to the decision making possible for the community in large and may determine the effect of deciding between possible investment alternatives. Externalities. Externalities also refer to external effects of the spillover over the important class output of the many benefits and disadvantages. They are generally defined as output as involuntary received or imposed on a person, group, or on an action by another over the recipient that has no control. Air pollution example, the externalities is not a benefit. Recipients accrue potential health, aesthetic, other disadvantages from the polluters from which they receive no compensation. For most investment decisions, particularly with respect to the public sector, it is not necessary to analyze depth and externalities such as environmental impact or in community economic parts of the life cycle cost analysis. The aspect of the alternatives to be considered usually treated in detailed parts of the environmental impact assessment, environmental impact statement, process, environmental documentation associated with the local and state process addressing environmental impact construction projects. However, the mention of the anticipated impact, both quantified and quantitative, in life cycle cost analysis documentation is appropriate. Alright, summary. There is no standard record format to prescribe the benefit analysis information. What's important but the case of the benefit, the content and critical national, no one else is true complete unless it's addressed benefit intending to alternatively under consideration. Relevant codes and standards: B100 facility stand with the public building, certificate E1765-16 stand with the practice analytical hierarchy path multiple attribute decision analysis investment related to project products and processes published by ACM and International Standard Building Economics 7th edition. Additional resource for the publication of 120 projecting estimate requirement of the public building, certificate of national performance based design guidelines for buildings, and P442 economic analysis handbook. And that completes the reading of principles of process for conducting life cycle analysis.